find that for certain questions that we do this year, I've given them names. Sometimes if you call a specific thing by a specific name and you remember the name, it helps you remember what to do. If you can call something, hey, this is a multi-revolution question, then it also helps you remember how to do it. So it's a teaching strategy that I do. Like, I've made up some of these names. So if you're like on your own, want to search up, oh, multi-revolution, it might be something that only I talk about. I don't know. Maybe someone else likes that and has done that as well. But I give it a name so that you can be like, recognize it. And if you can recognize something, then your chances of remembering the steps and remembering how to do it increase. It's a learning strategy. If you give something a name and you remember that name, you have a better chance of remembering how to do it. If you give something a name and you forget the name completely, chances are you've forgotten the steps completely, and you'll have no hope of solving the question. Okay, so a major type of question is a multi-revolution question. A multi-revolution question is a solving question that has a horizontal stretch or compression built into it. So we have sine 3x equals 0. So what are we going to do in a multi-revolution question? Number one, you are going to rewrite the domain for, and I'm going to put this, I put that in the green box because it could change, right? In this question, I have 3x. In another question, you could have 2x. In another question, you could have 4x. But you're going to rewrite the domain for whatever's inside. What's our domain right now? Our domain is that the x is between 0 and 2 pi. If 1x is between 0 and 2 pi, what would 3x's be between? In other words, if I got you to pick a number between 1 and 10, and then I told you to triple it, everybody's numbers would now be between what and what? Would anybody have 1 anymore? No. The smallest anybody could have would be 3. The biggest anybody could have would be 30. So originally it was between 1 and 10. 3 times it would be between 3 and 30. If x was originally between 0 and 2 pi, 3x's would be between 0 and 6 pi. And 0 and 6 pi, if we think about our circle, is once, twice, 3 times around. Multi-revolution, because we'd have to go 3 times around for this question. That's why I call it multi-revolution, because 1x is once around, 3x would be 3 times around. Step 2, we're going to solve for the 3x over its domain, over 3x's domain. If that was a theta, if you just had sine theta equals 0, you would say, hey, that's part of my axis family. When does that happen? Sine is equal to 0. Sine is which coordinate? X or y? The y coordinate. Here at 0. Also at pi. Also at 2 pi. But instead of writing theta equals, what do we have? We have 3x equals, we would have 0, pi, and 2 pi. But that is only once around the circle. What's its domain? Its domain is 3 times around the circle. So second time around, you would also hit 3 pi and 4 pi. And the third time around, you would hit 5 pi and 6 pi. Wow, I'm running out of room. And this question, you got to be careful. You see how, so sneaky. They didn't include 2 pi. Did you write an equal sign on your notes? There's no equal sign with the 2 pi. There's no equal sign with the 6 pi. So actually, this is too far. I have to take that one out. So that's what it means for solving 3x, just like solving for theta. Think about normal values where it's equal to 0. But we have to solve it over the domain of 3x, which was multi-revolution 3 times around. But the question didn't ask us to solve for 3x. What variable do we have? We have x. So now step 3, now we can solve for x. Well, how could I get x by itself? I'd have to divide by 3 or multiply by 1/3. So each of these answers has to get multiplied by 1/3 or divided by 3. And you could write just pi for that one. And when we divide by 3, notice that all of our values of x are now between 0 and 2 pi, like 5 pi over 3. Do we hit 5 pi over 3 in the first time around? We do. So all of our final answers are in the correct domain, between 0 and 2 pi. Then in part B, it says to write the general solution. So we wrote down our steps for writing the general solution. Step 1 was solve between 0 and 2 pi. We did that already in part A. We have circled right there, those are the answers between 0 and 2 pi. And now we want to write the general solution. So we could write each of them. 0, pi over 3. 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. And for each of them, plus 2k pi, plus 2k pi. We're done. That would be the general solution. Some of them you could probably combine. Like maybe you see that, hey, if I did 0 and pi as k pi, I could write both of them together. That's perfectly fine, but you don't lose marks if you do extra. But k pi would be more elegant. We could. Pi over 3. Well, what's the difference between pi over 3 and 2 pi over 3? Another pi over 3. So if you wanted to be like, okay, for those of you that like being creative, you could just do this. If k is 0, you would get this one. When k is 1, you'd get this. K is 2, you'd get this. K is 3, you'd get this. K is 4, you'd get this. K is 5, you'd get this. K is 6, you get back to the beginning.
Don't you like it more?
Oh, I do. But I don't. Like, this is easy. Just write them all and add 2k pi. Right? So I'm teaching you the easy way. If you want to be creative and combine them, sometimes you can. Makes your answer more elegant, but harder to understand sometimes. So that's why I keep the easy way. But this would definitely be shorter. Okay. Circle, question,